More than a century ago, welders first fused two metal surfaces by melting a metal stick over them using an electric current. That stick is known as a welding electrode. Farmers and mechanics often use this useful tool to repair heavy machinery. This company's electrodes are coated with powdered metals and minerals. During welding, the metals melt and the minerals protect the area from oxygen, which would weaken the bond. The electrode transmits an electric current that heats and melts both the electrode and the metal surfaces, welding them together. Thin metal wire forms the electrode's core. The type of wire changes dependent on what the electrode's designed to weld. In most cases, the core is made of carbon or stainless steel. A machine simultaneously spins and bends it, reshaping the wire till it's completely straight. 4 metal rollers then push and guide the wire into a guillotine. The blade chops the wire into segments that will become the electrode cores. The factory puts a variety of metals and minerals in the coating. The metals include nickel, manganese and iron. The minerals, alumina, magnesia and limestone. They also add a colorant to identify the different models. Workers mix the ingredients with a little glue until they turn to the consistency of wet sand. A worker then packs the mix into a machine that forms it into slugs with a hole down the middle. He adds a plastic cap. Then a metal cover slides on and the machine takes over. It takes only a minute for the machine's piston to compress the powder into a solid. To put the powder coating on the core wires, a worker loads 4 slugs into an extrusion press. It'll apply 120 tons of pressure to shoot the powder through nozzles that'll coat the wires as they pass through the holes in the slugs. To load them into the press, the wires are first stacked in this feeder. The opening at the bottom can be adjusted because core wires have a range of different diameters. These rollers pass them through the press one at a time. Four wheels then pull the wires from the feeder into the extrusion press for coating at a rate of up to 1,000 electrodes every minute. When the coated electrodes emerge, they hit a metal wheel that positions them on a conveyor. A sander removes up to 5 centimeters of coating from the bottom where you grip the electrode, and it bevels the tip so it conducts electricity even better. A worker now checks for uneven coating and to see if the wire's well centered. The coating dries at room temperature for up to 72 hours. To cure the coating, the electrodes are put in an oven and heated to 485 degrees Celsius for up to 5 hours. Once they've cooled, the electrodes head into a printing press. An ink wheel prints the model and the type of current that's required. Another ink wheel then applies a colour to the gripping end. It's another way to identify the model in case the lettering on the side rubs off in storage. From there, it's off to packaging. An optical scanner counts the electrodes. Then a stacking machine separates them into bundles. Finally, they're inserted into cardboard canisters. A piece of cardboard is added to compress them tightly for the trip. A sticker marks the contents, and tape keeps the package tightly sealed. And to that, we say well done.
slow up, no I don't take shit, I got no love